Hello, everyone. Thank you for attending another DB Sales and Service weekly webinar. My name is Austin Buckles. I'm the sales manager at DB Sales. This week's webinar presentation will be from Intellihot by Daniel Gonzalez and Jason Smith on how to go tankless in commercial buildings, as well as various other topics regarding Intellihot. If you do have any questions or comments during the presentation, please fill that out in the questions and answers window, and we'll be happy to answer that for you either live, or you can wait until the end to ask your questions. But with that, I will hand this over to Daniel to do a little bit further introduction on what we are doing and continue from there. Thank you very much.
Not sure if you can hear me, Austin, but
yes,
can you hear me okay?
Yes.
Okay, awesome. So hello, everyone. Welcome. We're so grateful that you're able to join us today. As Austin mentioned, I'm the Western Regional Sales Manager for Intellihot. We're the only commercial tankless water heater manufactured in the United States out of Galesburg, Illinois. So we're happy to show you a little bit about our background, how we got started, what makes us different from our competitors, and what our value propositions are. So without further ado, I'd like to introduce you to Jason Smith. He's our senior application engineer. He's been with our company now almost since the inception. We're a 10-year-old company, although we've had high growth over this period of time. And he's been a lead person that's been spearheading a lot of the direction in terms of where we're going on the engineering side. So Jason, I'll turn it over to you. And if you need anything from me, let me know.
All right, that sounds good. Thank you, Daniel. Again, as Daniel mentioned, my name is Jason Smith. I'm a senior application engineer here at Intellihot. Been with the company over 6 years now, basically dealing with sizing methodologies and drawings and specs and things like that, dealing with the outside people. So what we're going to talk about today is we'll go a couple different directions in here, how to go to tankless in commercial buildings. So we'll talk about how we can use tankless in commercial buildings, where the theory comes from, how it's evolved, and how it can be used in all kinds of different kinds of projects today. So we'll go through a little background here. That obviously everybody knows hot water is a basic need. Everybody needs hot water no matter what you're doing, no matter what your project is. So every vertical, every application needs hot water in one way or another, whether it be showers, whether it be to clean dishes, whether it be to sanitize linens, and everything in between. So hot water is a basic need. Everybody needs it since many times throughout history. You've always needed hot water for something. But the systems we currently use that are mostly utilized now are outdated. So how do you normally heat hot water? Okay, there's usually a big tank of water, whether it be how it's heated can be a little bit different, but you're basically heating a big tank of water, whether it be a tank type heater, whether it be a boiler tank setup, indirect, direct tank scenario. So, and it really hasn't changed the theory, or even the technology. I mean, there's been bells and whistles added, but it's pretty much been the same for the last 150 plus years. You've got a big tank of hot water, and one way or another, you're heating that hot water so it's there when you need it. And how, for reliability's sake, for safety's sake, to make sure it's always there when you need it, what happens? You need to install multiples. So at least that N+1 thinking that you have for redundancy, for capacity's sake, just in case you do have a down heater or a down tank, you'll have another one in reserve to make sure you've got enough to meet your demands, no matter what your application type is. What happens when you install multiples? Obviously, you take up more floor space because you're adding more equipment. You're adding more, so that in turn has a higher risk of leakage. You got more installation costs, you got more CapEx costs, you've got more OpEx costs, so operational costs, because you're heating that water even though you're not using it. So it's sitting there. So if you need 2 boilers and a tank, you've got 3 boilers, 2 tanks. So you've got a lot more equipment to pipe up. You got a lot more equipment to buy up front, and you got a lot more equipment to keep hot all the time. So you're increasing that cost, and you're increasing that floor space. And then obviously with that, you have the more connections you have, that's a lot of times where your weak points are. You have more possibility of failure in those points. You have a higher risk of possibly, because of storage tanks, and if they fail, you may have a higher chance of getting Legionella in those tanks. And obviously you have a higher risk of leaks through tanks or through piping as well, because you just physically have more equipment there that you're going through. So what we tried to do to try to make sure, we want to make sure we're giving you the right equipment, make sure you have the right equipment for your job. We don't want it to be grossly oversized, but we also obviously don't want it to be undersized, so that you don't have enough hot water when it's needed. So we've done a plethora of flow tests throughout the country, throughout all verticals, all application types, to try to figure out how is water actually used in certain situations. The way this is done is through an ultrasonic flow meter that basically just attaches straight onto the piping. It takes a snapshot every 10 seconds of the water flow throughout the system. So, or where the system's going, wherever you put the flow meter. So we use it obviously on the hot water system, because that's what we're focusing on here. So what we did was we take all this data and we collect it, and we want to kind of analyze it to try to see what exactly is going on in these applications. So to see if it follows traditionally the way people have been thinking, or whether it's different. So we started doing this 5, 6, 7 years ago, right as I started with the company. So this has been a ever evolving project, and it ever will be. I mean, we always want to make sure we're on top of things, but traditionally it does follow the same statistical law through, no matter which scenario we're going through. So here's an example. So we have a 4-point Sheraton hotel. It's a 320 room hotel. There are 3 full service restaurants in it. There's basically one catering kitchen that they use for all their banquet halls, and they have multiple banquet halls, multiple conference rooms, things like that. And then they had 2 other full service restaurants and a full service laundry as well, for in-house laundry for their hotel linens and everything. So when we took this was 95% occupied. And as you can see, we had a peak flow of about 55 GPM. Now, as you can see, we had a slight smaller peak down at the, let's say 7 to 9 a.m. range. That's your shower area. And then you started to peak a little bit higher right around between 11 and say 1 p.m. And that's when when the lunch restaurants started, but also when the laundry kicked on. So that, as you can see, we hit 55 GPM, not very often. We hit it a couple times, maybe a day, but you're looking at that. If you were looking at this, say in the old Hunter's curve method, or even the modified Hunter's curve, or many other methods that are out there, or even other manufacturers' methods, you're going to be a lot higher GPM flow rate that they will give you. You'll at least be double what we see here. So if we break this down a little bit further, you can put it down into these small little buckets. So whether it be low draw, small draw, medium draw, and a high draw situation. So 94% of the time we're looking at low to small draw scenarios. So you're looking at, it's a little bit of water's being used, and then the demand goes down again, or things like that. So that high draw, where you're meeting the quote unquote peak demand time, you're only at a couple minutes out of the day. So this one was, so you're less than 1% of the day. So that equates on average, you're looking at about 14 minutes is what it is throughout the day, max. So you still have to meet that peak flow, but we also want to make sure we're not wasting energy to always have that much water ready, even though you're not using that water all the time. as you can see with that graphic on the right, so what that shows is a firing rate of traditional, let's say 5-to-1 turn down boiler tank type setup versus a higher turn down system, like for example our instantaneous tankless heaters. So if you're on these low to small draw situations, you're looking at a boiler firing on and firing off and firing on and firing off over and over again. And what you're doing is you're wasting a lot of energy there. You have to fire at this higher rate just to, because that's the minimum rate. That's the only time it'll fire. So it's got to fire at that high rate, and that's going to come right back down. So you're wasting all this extra energy with pre and post purge things, along with burning more than you actually need. Whereas if you look at the orange line on the bottom, that's more of a nice smooth firing rate. Our minimum is 30,000. That's what this shows here. So we fire on at a 30,000. We get it's nice and smooth, and then it'll fire back or shut back off when needed to after we meet that capacity. So it's more, you're not wasting any energy, you're not wasting all that water, but you're still having that water available when needed. Here's another example. Like I mentioned, same kind of scenario. This is an 800-room hotel on the waterfront out in Boston. So this is just a larger hotel. Again, multiple restaurants, full service laundry, a high-end hotel. Your statistical percentages are more or less the same. So you're looking at the peak draws. We hit, I believe the peak was about 108 GPM. We hit that a couple times throughout the whole week that we had the flow meter on there. And otherwise you're way down in the lower end of this chart here. So you're in that low to small draw situation. So again, and you can see throughout all these other things that we've done, they all follow more or less the same statistical pattern. So here's a few other applications we've done. We've done anything from hotels to fast food to apartment complexes to prisons to a hospital. So we're in every vertical, and every vertical has their own statistical pattern. So what we've done is we've captured these patterns and we've kind of utilized them to make our own sizing methodologies. So here's a summary of how that hot water draw profile looks like. Water is consumed from very low to very high flow rates throughout the day. As everybody knows, there's times where you use a ton of water. There's times when you don't use any at all, or very little, where you're just using maybe a couple sinks or a shower or something. But what happens is in that low to small draw scenario, you're looking at 23 out of the 24 hours of the day. That's where you're at. So your peak flow occurs less than 1%, or that 14 minutes for every 24 hours. So you're trying to find a way to make sure we match those, try to get a piece of equipment that matches those profiles without wasting anything, without over firing, or without, like I said, wasting extra gas, wasting extra energy, and wasting extra water. So we've come up with a sizing methodology here at Intellihot. So what we base this on is we've taken those old hunters curves, those more conservative scenarios, and kind of created our own curves, dropped them down a little bit to a more realistic level, more on the GPM side as opposed to the GPH side. Everything with storage, obviously, you're looking more in the GPH range just because that's what it is. You want to make sure you have enough for that first hour peak. Or a 2-hour window, or whatever the situation calls for. But we're in more on the instantaneous. This is what's being used right at this moment, and we want to make sure we load match that. So say in a hotel, okay, everybody's going to shower from 7 to 8 p.m. or a.m. So you want to make sure you have a lot of water. So you're saying, oh, everybody may take a shower in that hour. That is true. I mean, but all the showers are not going to be on simultaneously. Throughout all the studies we've done, you're looking at a certain diversity where it's a lot smaller than you would think, because they're not all turning on the shower and turning off the shower at the exact same time. And that average of 6 minutes for shower, they're not all turning it on at 7:04, turning it off at 7:10, and then they're done. So throughout the whole thing, you're turning on and off depending on where you're at in the building. And we've taken all this into account, and then we've created our own sizing methodology. So we do guarantee every one of our sizings. So if for some reason you utilized our calculator or contacted us directly and we didn't, and it didn't work, or it wasn't the right capacity, we would give free equipment. And we've been guaranteeing this for 4 to 5 years, and we have yet to capitalize on that guarantee. We do have online sizing tools. So here we do have a web-based version, and we also have a mobile version. So here's a snapshot of the web-based version. It's very simple to use. You choose your business type. Once you choose that business type, we've got, I think 11 or 12 businesses types in there. And you're looking at that, say, this is hotels, hospitals, apartments, restaurants, run the gamut. You drop down that menu, you pick on which one you have, and then a bunch of fixtures will come up right underneath there. That will be typical fixtures, what you would see in that kind of application. You fill out all the fixtures that you have, and then you have a couple other options underneath that, whether you want ASME specific equipment, which most of ours are anyway, whether you want wall mount or floor mount, or either one is an option. Whether your fuel supply is natural gas or propane, all of our units do run on either that are field convertible without any additional equipment. And then your water temperature. So you want to see what your incoming water, depending on where you're at, what fixture temp your water is going to be used at. So if you're most like a hotel, 105 there that you see is the typical shower temperature or the average shower temperature. So that it takes that into account as well. And then your unit set point, what you want the unit to be set at. And also, if you're in a high altitude area, if you're designing a building, or if you're installing a system somewhere in a higher altitude area, we will also take that into account. You put all that stuff in, you could calculate project size, and the next screen is over on the right, where it'll show you what up to 3 options of models. So you may have, like here, you have 1 larger unit, 2 smaller units, or 3 even smaller units. So they'll all meet the capacity of what we anticipate you to need. And it also gives you what the estimated project requirements are at the top. So how the calculator works is we take all your fixtures you input, just like you would in an ASHRAE or an ASPE table. We come up with fixture units. So we get a total number of fixture units, and where we differ a little bit, or where our numbers are a little bit different, going from fixture unit to estimated flow rate. That's what you would normally look on the Hunter's curve. We look up our own curves, and that's where our numbers would come. And then we move on to that design load. That design load actually adds in an additional heat exchanger, which I will talk about in a second, as a safety factor. So we do have redundancy in there. It's just a smaller redundancy because of the modular system and the way our units operate, which we will go over here in just a second. And like I mentioned, there is an app version as well. It's very similar to what the web-based version is. So you do the same thing. It's called Intellihot. You can download it. You can play around with it as well. So, one thing I forgot to mention here, on the right snapshot there, if you put in all your project information, you'll get an email back that's got the summary of everything you've done, and you'll get an output that has, like I said, the summary of what you select, or the selection, and then it'll give you a submittal for that particular selection, and also a piping diagram of how that we suggest that pipe or that unit or bank of units should be installed. And like I said, same kind of situation here. So you pick your application, you go through your fixtures, you go through your options, temperatures, things like that, and it'll spit out the suitable models for your particular application. So like I said, we call ours right sizing. It's more on the realistic side. We don't add in a whole additional large unit like 1 million, 2 million, 3 million BTU unit just as an extra N+1 redundancy. We add that extra additional heat exchanger, which we'll talk about here next. So here is a tankless approach. So this is a modular tankless design. All of our units are. So what will happen at small small flows, 1 or 2 modules may be firing. So each one of these little cylinders here represents a heat exchanger inside of the box. Each one of those is rated at, say, 250,000 BTUs. So these two cabinets, these two models indicate 1 million BTU units. Inside each individual cabinet, the modules communicate with each other. They're connected, but they work autonomously. They all have their own control board. They all have their own burners, gas valves, blowers, everything else in there. So they're really their own entity inside of the cabinet. They just communicate with each other. And that being said, there's no master in there as well. So one's not going to be firing first all the time, and then in sequential order, they'll even out their firing, whether it be inside one cabinet or if you have multiple cabinets put together to make a higher capacity system, they'll also communicate the exact same way. So heat exchanger 2 in cabinet 2 may have fire on first, or it could be heat exchanger 4 in cabinet 1. It all depends on the runtime, how many fires, the firing time, firing rate, city versus highway driving, whether it's on and off, or whether it's a nice smooth transition. It takes all that into account because we want to make sure we're evening out the wear and tear on all the modules and all the pieces of equipment inside this cabinet. So how the modularity works, how the system works is that one will, let's say at small flows, 1 module may be firing. So you got that, once it hits that 30,000 BTU threshold, it'll fire on. Whichever one is next in line to do it based on the wear and tear algorithms that are inside the unit. It'll fire on at that low rate. It'll slowly ramp up to what it needs to be, or not slowly, it'll ramp up to wherever it needs to be quickly to where it ever needs to be. And once that one module hits about 60%, and then it'll queue another one to fire on. So, and then they'll drop down, fire on at a lower rate together, and then they'll fire up together, and then so on and so forth. As of course the flow or the demand based on that BTU flow rate, the flow and the delta T, obviously as that gets higher and higher, more BTU is needed, so more units will fire on, more modules will continue to fire. At that peak load, all the modules will turn on, but we still have reserve capacity. Like I said, when we do our sizing, we do include 1 extra module here. So for example, if we calculate everything based on the flows and everything, and right at it, you need, say, 750,000 BTUs. We're going to add another heat exchanger, which is 250,000, and we will suggest you use a 1 million BTU unit. The reason for that is, should one module go down for any reason, say, I mean, there's mechanical components and there's something could happen, something get into the blower, we could have a igniter broken or something like that. So let's say that does happen. All the other ones inside that cabinet, but also all the ones in the adjacent cabinets or any ones that are connected in that unit will keep firing as needed. So you'll never be 100% without hot water because there is no master, there is no single point of failure in these systems. That one that's got an issue will isolate itself hydraulically and hydronically. It'll shut the valve itself off. And then the rest of the modules in that system will continue to fire and meet the demands and the needs of the building that it's providing hot water to. And that's a big key here. The single point of failure, which really you don't have. The only thing that could take a whole cabinet offline would be a power failure, or all of a sudden you lose gas to the building, or something like that. So there's very little. The only thing that's common in the cabinet itself is the display, which is that little white box right in the upper middle part of each one of those module or each one of those units. You can actually cut the display off of there and it will still fire or still run as at the same settings as it had it before. So like I said, inside the cabinet, there really isn't much that's going to cause the entire unit to go down. So that single point of failure is basically non-existent. So the heat exchanger, you need a robust heat exchanger in order to maintain and to keep the quality of the unit firing when needed. So we're always going to heat water on demand. As you can see, the water goes in the bottom out the top. It's a downward firing burner. It's a 316L stainless steel heat exchanger. It's a very robust, full 3/4 inch, which is a lot larger than other tankless on the market. And it's a very robust material, and it's very robust design. It's one big piece. There's no welds on the water side. There's fins on the outside. Those are laser welded, but those are not on the water side. But it is one big piece of steel coil, basically. The water's always moving through these. So that's going to keep the scale in suspension, any kind of solids moving. It'll keep everything going through. So these also have a lot less tendency to scale based upon that turbulence, but also based upon the material that's being used and the fact there are no welds on there. It's for the scale to stick to or to have a weak point in the system. We've had well over 300 million hours runtime on these heat exchangers without a material failure. So these aren't going to crack. You're not going to have pinhole leaks like you would with a copper or a lower grade steel heat exchanger. So here's some old thinking versus new thinking here. So traditionally, which we kind of touched on before, you need more of everything to make sure you have that reliability, make sure you have that water always there when you need it. This is a quick estimate for a 100-room hotel. These are just rough numbers based on industry averages. So whether you have 2 boilers and 2 tanks, 4 100-gallon tank type heaters, or one of our tankless type heaters. As you can see, capital costs, ours are about, the Intellihot system is about half the cost. And the operation cost, due to that modularity, due to that load matching of that firing rate, that capacity needed, you're gonna have a lot lower OpEx costs as well. One other big key that may be important to a lot of people is space. Space is very valuable depending on how you're doing it or what your application is. So you can also cut your space down by 60, 70, 80, sometimes 100, 200%. Because you don't have all that storage, you don't have that extra redundancy, you don't have all that extra material to deal with. And then you're at the bottom line there, 10-year lifetime cost, that just takes everything into account. You're saving a lot of money by going tankless, and you're saving because of that capex and that OpEx cost that you're saving throughout the life of the system. So here's an example of some space savings as well, which is kind of an interesting way to look at things. This was a hotel, I believe down in Texas that we were competitive on here. So we got 2 Intellihots versus 4 tankless heaters. So you're looking at 211 square feet needed versus 87 square feet. That's 142% more floor space that are needed on this due to, again, the tank type heaters, because you're storing that water, because it's taking up all that room. These are with the manufacturer's suggested clearances on them. So you're looking at a lot less space to take up than traditional systems. Here's another one. This was actually a restaurant down in the Southeast. We saved 83% of the floor space here. This was like I said, a restaurant application. We went 2 tanks versus one of our smaller tankless, but multi-hex tankless units. We're saving a ton of space, which actually we have a picture of right there. That's the real system that we did. Replaced 2 of those tank type units with a single tankless heater. So you can see a lot of the clutter's gone. You have a lot more space where you can, whether it be storage, whether you got another piece of equipment you need to put in there, you put a softener in there, you've got a lot more space to do what you want to do, or even just have space in there to move around to do your thing. So that space can be utilized. That's another big key on how to, or a benefit to go into a tankless type system, whether it be in a retrofit, whether it be a new construction. A lot of times plumbing takes a backseat to a lot of things. So as many of you may know, or probably do know, sometimes it's an afterthought. So everybody gets in there and you have to fit a tank or a water heater in a closet or in the corner, or you've got this little square foot of floor space. Hey, make this work. This is what we got. This is what you got to do. So getting rid of extra piping, getting rid of extra tanks, getting rid of extra units, that's sometimes is a key ideal that you need to come up with. There's just a quick snapshot based on averages as well. You're looking at, this was a restaurant type, quick service, full service restaurant, gallons of water used per day, going from a 96% efficient tank type heater to a high efficiency tank heater as well. You're saving about 30% on your overall gas costs. So your operational expenses are going way down just because you're not there. And there's a couple different reasons. Again, you're not storing that water that you're not using. You don't have all those extra purging cycles or purging losses. You don't have standby losses from the tank. You're heating water on demand. So you're heating that water as it's needed. And here's a quick snapshot of Intellihot's product line. So we go all the way down to 200,000 on a wall hung type project or a heater. The 200,000 is actually a 199, so we're under that ASME threshold, which most of you in California, that doesn't pertain to you as much, but it's there if you're ever doing anything outside of that. And then anything with an IQ or an IN, all are ASME rated, so they're all ASME certified. The number afterwards is the number of thousands of BTUs that are in that. So an IQ 251 is 251,000 BTUs. Those are about the size of I would say a suitcase. They're wall mount. That IQ 251D, which is labeled there as the industrial, that is for deionized or reverse osmosis water. And as many of you know, if you've ever dealt with that, that's very corrosive water. It's so pure that it eats away at everything. So we've designed a heater that can actually heat that kind of water. Can also be used as a pool heater for chlorinated water as well. We've got one actually just down the road from our factory that's got 3 of those installed in a municipal pool. So it can be used in that as well. Those are all single heat exchanger units. And then we go up to the 401 and 501, which are multiple heat exchanger units. Those have 2 in there. So that's 400 and 500,000 BTUs. Those are a drop-in solution for a tank type heater. So if you're replacing a tank type heater in a scenario and you have the exact same floor, you pull that out, put one of these in. It's got the same basic connection sizes and basic connection locations. So there's be very minimal piping. You go up to those large ones, those first couple, the 751 and the 1 million, they're about the size of a small refrigerator or a full-size refrigerator. They're all 30 inches wide. They fit through a standard doorway, fit through a standard elevator. They don't weigh a ton, so you can also sometimes save on structural reinforcement if you're taking it up to like a penthouse or anything like that. So they all have the same module, that same 316L stainless steel heat exchanger module inside of them. It just depends on how many of them are in there. So they've all got the same module in there. It's a number of them, depending, will give you the full capacity of the unit. So we go all the way up to 3 million BTUs in one cabinet. That 3 million BTU cabinet actually has 12 modules inside. So there's a bunch in there to give you that high amount of capacity in the size of a refrigerator. All these can be connected to BMS if you have a need for that in industrial application a lot of times, or in a factory or things like that. And then there's also an app you can monitor your system with. So which is called that Telecare right there. You can watch what's going on in your system. You can keep an eye on it. You can get alerts if there's anything wrong with it. You can watch and see how much water you've used, what the temperature is, what's going in and out right now, how much it's firing at the moment, and all the information is all in one app that you can hook up to these units through Wi-Fi. So who uses Tankless? Here's some scenarios of some success stories that are using Tankless right now. This is a 1,000-room hotel in Florida. right outside of Universal Studios, actually. There's over 1,000 rooms. There's 6 million BTUs worth of tankless heaters in that particular application. It's a little bit smaller scale. Seattle, Washington at 4 points. Again, 2 million BTUs there with no problem, no storage. All these have 0 gallons of storage in them. Casinos, you see a lot of those. Casinos are a little bit different. A lot of times they have low room volume or moderate room numbers, but they have a ton of restaurants. So you got to take that into account. Tankless obviously can be used in those as well. Starting to see a lot more high schools and school districts, and whether it be K-12 or whether it be colleges, using this as well. They're seeing the benefits of a lot of especially the older schools have these large, gigantic boilers in them. And they're starting, obviously, to fail. They're very inefficient. And they have to shut them down. A lot of times they want to shut them down in the winter because they're providing the heat, or I'm sorry, they want to shut them down in the summer because they're providing the heat in the winter, but they don't want to heat these huge boilers in the summer when there's no heat required and you're only using it for a little bit of hot water. So they're taking that into account and saying, hey, there's got to be a better fiscally responsible way to do this. And a tankless and on-demand system is a good way to do that. A residence hall, this is the 330 room dormitory. There's 1,500 MBH in this particular residence hall. So again, who's using Intellihot or who's using tankless overall? Thousands and thousands of applications. There's restaurants, you got schools, we've got stadiums. Levi Stadium out in San Francisco have some of our units in them. We are one of the 2 approved vendors for Marriott corporate. Marriott wants to go completely tankless now. They do not want tanks and they don't want mixing valves. So they're trying to get rid of both of those. So Marriott definitely does prefer the tankless technology. Hilton is also trending that way as well, and we've been in works with them to put things together for Hilton as well, and Holiday Inns have used those. So any hotels and also multifamily type applications as well. We have retail change. We are the national spec for Costco. Any new Costco's you see come up, we'll have our units installed in them. And then we're seeing a lot of prisons as well. So prisons are starting to come around. Again, the municipalities are seeing the savings as it comes to water and gas savings, so that because the water demand, a lot of times you have a lot in one spot and then you're done for a while. So you don't want to keep using all that energy, all that stuff to make sure that the water's there, but you're also wasting that energy when you're not using it. So what is Intellihot's proposition? As you can see, the conventional approach versus the tankless approach, you can cut your CapEx by 50% at least. Many times you can lower your operational expenses depending on the situation and depending on what you're replacing. You can go from 30% anywhere up to 70. We've seen 75, 80% of reduction in that OpEx cost just because it's more efficient, because of the way the technology and the way the brains of the units are running it. You can cut that space need by 80% or even more. And because we have that internal redundancy, that internal modularity, you don't need to double the equipment, which again leads to even more CapEx, more OpEx costs, and more space taken up. So I'm gonna leave this up for questions. I think actually before we do that, I think Daniel was gonna try to show a quick little video on how to, or on the guts of the unit itself. So I'll pass it over to him and he can fire that up.
Can you guys hear me okay? Austin?
Yeah. Can hear you.
Okay, awesome.
Yeah.
Good. Yeah. Thank you, Jason, for running us through that. Just a few things that I wanted to highlight very quickly. First of all, one of the very cool things about our product is that Legionella is almost eliminated with this solution. Obviously, it's something that's big, that happens in a lot of places, whether it's through stratification, tepid water. Anytime you have a situation where there's a tank and boiler, whether it's indirect or direct, there's sections where, because of stratification, you're going to have the potential for Legionella to build up. Because we don't store any water, a lot of times we can alleviate this from happening most of the time. Another thing that I want to say is our heat exchanger has a 10-year warranty, non-prorated from install. So in regards to some of the competitors out there, especially with Tankless, that's probably one of the better ones in the industry. Part of the reasons why we can offer such a great warranty is because we also have some technology built into our heat exchanger, which allows for scale to break up due to a vibration that this video will show. And then it allows the scale to break free through suspension. So that's a pretty cool thing too. A lot of times when people are thinking about going with a tankless system, whether it be something that they've seen from the past or something that they're looking to do for the future, in some of the other competing lines, that's been a major problem. Another part of that reason too is because their orifices are usually smaller. Usually they got about a 1/2 inch versus ours being a little bit larger. So let me go ahead and play this video. It's very short. It's about 1 minute and 32 seconds. And if you guys have any additional questions thereafter, we're more than happy to address anything you got.
Let's take a trip inside one of our floor standing units. We'll set our output temperature to 190 degrees and open up the case. Under the hood, you'll see that our floor standing units have multiple heat exchangers, each with its own dedicated controller. At the heart of our heat engine is a single-fin stainless steel coil that is designed to float freely. This unique feature allows for rapid thermal cycles by allowing the coil to expand or contract as needed. Cold water enters the coil at the bottom and is heated precisely to the set temperature before emerging at the top, ready for use. The modulating premix burner fires radially outwards to precisely match the load. Flue gases move downwards to the bottom casting while water flows up in the opposite direction, absorbing maximum heat along the way. By condensing the flue gases, an additional 12% heat is absorbed. The condensate flows downwards in the same direction as the flue gases, thereby preventing any gas side fouling. Our heat exchangers also have the unique feature of being self-descaling. Our patented vibration and turbulent flow technology keeps limescale in suspension, thus ensuring years of like-new operation. These features and many others can be found in our line of intelligent water heaters only from Intellihot.
Okay, so with that being said, if there's any additional questions, Jason and I are happy to address any if there is some, Austin.
Hey, Daniel, this is Steve Mertz. Can you hear me there? We did have a question come in from one of our clients here, and I just wanted to see if you could answer it live about is there outdoor capabilities with the units?
In the sense of, are they outdoor?
Can you install them outdoors? Yes.
Yeah. So I can tackle that, and then Jason, if you want to touch on it, that would be good as well. We do have specifically designed outdoor rated units. Obviously, it's something that we deal with more on the coast, whether it's West Coast, East Coast. The way they're designed is the cabinets actually have the in-touch screens on the inside. So they have proven to be a lot more durable than the original design. So the answer would be yes.
Sounds good. Thank you. Another question that had come in, just we answered it in the chat here, but just to answer it live for everybody. Do these units have built-in recirculating pumps?
Yeah, they do have a pump. Jason, do you want to touch on that briefly, real quick, to explain how that works?
Yes. Yeah. So, the answer to the question, there is a pump internal to the unit. They cannot be used as a building recirc pump. It's just not, they're not big enough in general, but that's more for what that's twofold for internally. It helps with the pressure drop through the unit to help maintain a lower pressure drop through the unit. And it also keeps, what I like to say is like, it keeps the units primed and ready to go. So it kind of makes the unit so it's ready to go when it's needed. But I think if you're looking at it for it, hey, do I need a separate building recirc pump? And the answer is yes. If you for that type of setup.
Yeah, and typically on most of your buildings, especially existing, there's going to be recirc pumps already within the system. So we wouldn't recommend you removing them if that was what you're looking for, Steve.
Well, yeah, it was a question from one of our consulting engineers, I think, maybe asking for possibly for a new design.
Okay.
Yeah. I'm not seeing any other questions coming in.
Just a few things to note. I know in the field, a lot of times it comes up later, is a question in regards to water hardness. We have our own charts that we follow. It typically is based on three things. It's based on unit set point. It's based on gallons per minute or grains per minute. And then it's also based on incoming water pressure, so PSI. So we have a chart that we use, and basically it will tell us where the range needs to be in terms of maximum water hardness. Do you want to touch on that at all, Jason?
Yeah. So yeah, like Dan said, if you look at, if you need to know that, there's actually a chart in the back of each one of our manuals in the warranty section that says it's like a 3-pronged thing. It's got temperature, set point temperature. It's got across the top, it's got or I think it's on the left actually, and then it's got your PSI pressure, what your water pressure is, because the higher the pressure, obviously you're pushing more through it. It's not sitting there at a lower velocity, a lower pressure, so it's going to tend to not scale up as easily. So you've got pressure, you've got temperature, and then it'll give you what grains of hardness we allow in our warranty itself. So you'll see a lot of other manufacturers, they will have, hey, this is the 1 grain set of hardness. This is what you can do, and then after that, we did it this way, just because there are different parameters. We can, and because of the design of the system, because of the, like I said, the heat exchanger, because of all the technology, because of the way the flows work, and the velocity that actually goes through the unit, we can handle more harder water than most tankless units can. And that's a good thing, and that's something we do pride ourselves on. Again, if you're sending stuff with a ton of hardness through it, it's going to scale up. I mean, everything scales up at some point, but we do have limits, but our limits are a lot higher than, say, most other tankless manufacturers.
Another thing that's kind of cool too is our product, the way we design things, we can match for a high temp or low temp situation. So let's say, for example, we've been using hotels a lot, so I'll stick with that. Let's say in a hotel setting, maybe for the rooms and the fixtures throughout most of the hotel, they need lower temp with lower set points. But maybe in the laundry facility, they need higher temperatures. we have a system where we can actually allow one of our units to be a booster. And if you need to get to 140 versus 105 or 120, that can be done. So there's a lot of autonomy within the systems, and there's a lot of different ways that we can use it to apply to the solution that it is that you're looking for.
Hey, Daniel, we have another question coming in from another one of our clients here. They're asking, can we base the capacity of the unit on the total square foot of the building? And I know we don't typically size that way. We typically size the fixture units, but
Yeah, I can take that one, Steve. So I would say the short answer is more or less no, and you can do that because that's more of the way you would do a space heating or a closed loop boiler system, because depending on the situations, there's going to be different kinds of fixtures, different kinds of serras, especially in an on-demand situation. With a tank type heater, maybe you'd be able to do it a little bit easier, but with a tankless type heater, we want to get more precise. We want to make sure we're giving you the right system. So we want to make sure we get a fixture count, or it doesn't have to be down to the one lavatory, but we want to get very close as we can so that we know what's being used and how it's going to be used in the system itself. So the square foot of a hotel, that could be a little bit different depending on the clientele. It could be different on the number of rooms. It could be different on how many stories it is. I mean, how many hotels are in it. So we took care of that. We took care of that with our sizing based on the fixture. So it is a little bit harder for us to do it based on a square footage, like you would on a space heating type scenario.
Yeah, and most of the reason why that is just to bring out what Jason already said, is we size to match the load of the building at the given time. So if you were to look back at that chart on one of those slides, it showed that majority of the time the building is operating either a medium or small draw. It's very small percentage of the time that it's calling for maximum capacity. So typically, as long as we have a fixture count, that will allow us to get to where we need to be to size it properly.
okay, then we have another follow-up question on the outdoor. What are considerations for the installations exposed to ocean air when you're installing these outdoors?
You want to take that, Jason?
Sure. So yeah, there are considerations taken for that. Like I said, Dana said that we've taken the screen, brought it on the inside, so it's not going to affect that. We've upgraded our paint. It's got a different paint scenario on it, and the doors themselves are a little bit different. So all that's taken into account, so it can withstand that. As you probably see, some other ones will rust up and at the drop of a hat when you get that close to the seaside. So we have taken extra precautions, extra care, I guess, in creating these and upgrading these cabinets, especially to make sure they are not the internals aren't exposed to the elements, but also to make sure the cabinet itself stays the way it should.
Yeah, and we have a lot of projects riddled everywhere that are already along the coast. I mean, I'm in Southern California, Orange County. We have our units at SpaceX, a ton of different locations around the ocean. You go to Pacific Northwest, they're in all the Microsoft locations. So it's all near ocean air. Our parts typically for most of our units have a 2-year warranty. So if there is an issue, that's one thing that we pride ourselves on, is great product support post sales. And a lot of times if there's an issue, we can address it. You there still, Steve?
Yeah, I'm still here. I don't see any other questions coming in right now from the audience. So if anybody else has anything, feel free to ask now, or
Forever hold your peace.
Yes, exactly. If not, we'll wrap it up here, as the hour is drawing here close to the end anyway. But And I'm not seeing any come in, so I guess yourself or Austin, if you wanted to sign us out here.
Okay, great. One thing that I will say just to everyone here is, you know, DB Sales is a big partner for us. They've been affiliated and working with us as a partner now, I want to say for almost going on 7-8 years. And so know that if you decide to work with them, they're highly experienced in our product, very good at, you know, sizing and things of that nature. There's a ton of projects that they've done with us. And most importantly, they have the support of the manufacturer. So we stand behind them 100%. I'm not some guy sitting in a cornfield in Illinois. I'm right here in Orange County. So if you want to see me, let me know. And I really appreciate the opportunity for Jason and I to give you guys a little bit more info on our company.
Yeah, yes, thank you very much for the presentation. And again, yeah, your support on the product is very much appreciated. The continued support that we get from you, you know, on various projects that we have is very much appreciated. But thank you again for giving the presentation. We do record these, so if anyone wants to view this again or send it to another person or recommend it, we load these up on our YouTube channel. You can find it at dbsales.net, and you can load the video there, forward it to anyone you might have. You can also get in contact with me or access through our email account, dbsalesca@dbsales.net, to ask any further questions about that. Next week, we have our next webinar on the 30th is Smart Design with the Array from Riello, multiple heat exchanger platform. Please feel free to join us for that webinar as well. But with that, thank you very much again for attending, and thank you very much to our presenters. Have a good rest of your day.